Welcome back. Today I'm going to be going over some vocabulary that concerns ABS, TCS, and SCS. So that would be anti-lock brakes, traction control, and stability control systems. This is one of those basic things that if you're getting into working on cars, you need to learn the terminology, what things mean, and all that good stuff before we start. So this would be kind of if you're in your brake section and you're starting to do an ABS unit, this would be where you start with. Or if you want to learn about ABS, you probably should know what the terms mean before you get into how it all works. And I'll actually go into how it works a little bit in this video, but not a lot. So the first thing that we've got is a wheel speed sensor. So this is a magnetic pickup or a Hall effect sensor that tells the ABS control module the speed of the wheel. These sensors in today's car are on all four wheels. When ABS was starting out, sometimes there would be one for the entire vehicle, but now they're on all four wheels. So when it was on just one wheel, it was generally called a vehicle speed sensor or a VSS. But now today we have one on each wheel of the vehicle, or four wheels. I'm going to show you one of these, but I'm going to wait until we get past the next one. Okay, the next one is a sensor rotor. This is a toothed rotor that rotates the same RPM as the wheel and tire and is read by the wheel speed sensor. This is an example of a wheel speed sensor. This is just a simple magnetic pickup style. In fact, if I bring it in here, it's a magnet. So this is a magnetic pickup style wheel speed sensor. This is our sensor rotor. This one is split in half. That's a fairly common thing that happens in Michigan for the exposed sensor rotors. So the way this works is this would have been pressed. So this would have been pressed together, but it would have been pressed on an axle shaft. So the tire would be here. The axle shaft that spins the tire, this would be pressed onto the outside, and the sensor rotor would read the teeth on this to determine the speed of the tire. Now, the reason these crack here in Michigan is because the CV axle is generally made out of iron or steel, and it rusts, and as it rusts, rust expands. Well, as it expands, it puts so much force on these sensor rotors that they'll actually crack. Now, this is one example. This is a visible sensor and rotor. Not real common to have them visible like this. Most of the time, these two components are actually housed. This is a wheel bearing or hub assembly. This wire coming off the back is connected to the sensor that sits inside of here. And then within this blue cup, there is actually a sensor rotor that spins. So if we look at how this works, if I hold this part, this area of the hub would be connected to the steering knuckle. As this spins, the sensor rotor is spinning inside of there, and as it spins, the sensor actually picks up a reading off of that. This particular one would generate an AC voltage. So this is kind of an older school one. So this is kind of a pretty common type of wheel bearing you'll see in the automotive world. So this would be one that is all sealed and you can't actually see it. So air gap is simply the space between the sensor and the rotor. Now, in order for this sensor to read properly off this rotor, it has to be spaced appropriately. If it's too close, it's not going to get a proper reading and potentially run into the rotor and cause issues there. And if it's too far away, it's not going to pick up the ridges or the definition on this rotor. So there's going to be a spec for that. You need to look that up for whatever vehicle you're working on. So this is not a real common one, but with this style, you'll actually get a feeler gauge out, and you'll set the distance between this sensor and the rotor so that it picks up properly. Now, you can't set the air gap on this style of wheel bearing, but it is still a factor. So as these things get rusty and corroded or the bearing starts to fail, so as the bearing starts to fail, this part will tilt as this part stays separate. So the wheel part will tilt as the hub mount stays in one spot, and it pulls the sensor away from the sensor rotor, which actually changes the air gap inside of that. It's not adjustable, but it is still a critical measurement on this. Chevy trucks used to have a really common issue where the sensor would actually bolt down in through so the sensor was actually bolted onto the top of the wheel bearing here, and rust and corrosion would build up and it would actually lift the sensor a little bit, causing too much of an air gap, and you would get some weird ABS applications out of that. Okay, this is another little section here where I'm going to go through a few different definitions, and then I'll show you the stuff. So we've got the ABS control module. This is the computer that uses wheel speed inputs to control ABS modulation. And so this is the computer part of it. There is a computer that is dedicated to just anti-lock brakes. Maybe I should rephrase that. This computer is dedicated to anti-lock brakes, and nowadays it's also stability control, and it functions in traction control, but is not necessarily... Yeah, we'll say that traction control is kind of a floating thing. It's probably involved in traction control too. So this computer does ABS, TCS, and SCS. So all the stuff that we're talking about, this is that computer module. It talks to all the other computer modules in the vehicle though, or at least the powertrain ones. It might not talk to the module that runs, say, your Windows or something like that, but it's going to talk to the modules that run the engine and the performance of the vehicle. So the next part here is the hydraulic modulator. This modulates the brake pressure to the wheel assemblies during ABS operation. And I have ABS down here, but it's also TCS and SCS. So this hydraulic modulator controls where the hydraulic fluid pressure is going in the vehicle during an event that turns on the ABS, TCS, or SCS. So that would be your hydraulic modulator. Okay, so fluid reservoir, this is the part that contains or holds the surplus brake fluid in the system, the brake fluid that's not necessarily being used. And there's kind of two different spots where this works. One of them is here in the master cylinder, so our reservoir up top, this is a brake fluid reservoir, obviously. Now the other spot that we're going to have a bit of a brake fluid reservoir is actually within the module that has all of these other parts to it. It's not going to hold nearly as much as the reservoir on the master cylinder, but there should be a little bit of a surplus within the ABS system as well. The solenoid valve block. This is the block that holds the solenoid-operated valves that control brake fluid flow to the wheel assemblies. So these are the actual solenoids that are controlling where fluid goes during an ABS or TCS or SCS event. So the accumulator is the high-pressure storage container that stores pressurized fluid for ABS operation. And this has kind of changed a little bit throughout the time that ABS has been around. There used to be like this ball that would hold pressurized fluid. We don't really have that anymore, so it's a little bit different than that, but that's what that is. It actually holds pre-pressurized fluid in case it needs pressure during an ABS stop. The hydraulic pump and motor. This is an electric high-pressure pump that provides pressure for the ABS system. So when this thing engages, it actually pressurizes brake fluid, builds it up, and then it gets used for the ABS. These last few slides that I did are all held in the same unit. So this would be an example of one of these units. This particular one, I think, is off of like probably like a late 90s, early 2000s GMW body. Honestly, a lot of the newer ones I've seen look pretty similar to this. This is kind of where the size they are, what's involved in them, all that good stuff. So let's go back through here. Okay, so we'll start back at the beginning portion. The ABS control module. It's this black plastic piece that's held off the end. This one is bolted on here. It's got a big connector that goes into the solenoid block up here. But the computer is right down in this area. So from like here to here, in that little area, that is our ABS control module. So it's not a real big piece. If you look at it from the top side, that's where the connector actually clamps on. So when we plug this in, the connector is right there. Okay, so that is our control module, the computer, the brain of the system. So the hydraulic modulator is kind of this whole area right in here. There's stuff going on inside of here that modulates pressure. that modulates the pressure between the different wheels as they go through an ABS stop. And if you look at the top, there's 4 spots, 1 for each wheel, and then there's 2 right here, which is the feeds into it, I believe. Don't quote me on exactly what this is set up like, but there are 6 ports. 4 go out to wheels, 2 come in. So the solenoid valve block, these are the valves that the solenoids that actually control the valves. In this particular unit, they're right under here. They're electric valves. So as it gets commands in from the ABS module, it controls these valves, which then control where the fluid goes and how it works inside of here. The hydraulic pump and motor. So here's our hydraulic motor, and if we look at it from the bottom side, we've got 2 fairly heavy electrical cables that come up, and this end right here, this is an electric motor that spins a pump, and the pump is also held within this aluminum housing. So there's a lot of passages going in. There's a lot of passages and a lot of stuff going on inside this little aluminum block. All right, so hydraulic pressure modulation. This is the pressure being applied and released from the wheels. So this is pressure being cycled on and off to each wheel assembly. Okay, so in a modern system, we have one for each wheel, but we'll get into those a little bit more too. Okay, isolation mode. This is the first step in ABS operation. It happens when the ABS module detects a tire locking up, and it isolates the hydraulic system from the rest of the system. So if you're driving a car and you're driving it in winter, which is, I'm making this video in winter. So you're driving a car with ABS and you step on the brake, the ABS starts to work, and all of a sudden the pedal gets really stiff and you can't actually press on it any harder no matter how much force you put on it. That's because it's in isolation mode. What it's done is it's broke the connection. So if this is your foot on the brake pedal pressing forward, and over here is your wheel end, so normally you would press and it would press. Well, when it goes into isolation mode, it basically cuts off contact with your foot and makes it so that your foot no longer controls the hydraulic fluid going out to the wheel. Like, it really takes it totally away. The ABS system is capable of applying more pressure than you were. It's also capable of applying 0 pressure, and it does that to try to stop the vehicle in a safe, controlled manner. Dump mode. After it goes into isolation mode, the hydraulic modulator releases fuel pressure from one or more of the brake assemblies. This allows the tire to roll. So what the ABS is doing is you're driving down the road, your wheels are all spinning, you hit the brakes, and instead of a nice gradual slowdown when you hit the brakes, you're driving down the road, you hit the brakes, and boom, it just stops. The ABS sees that. It knows that that means that that wheel locked up. It's not turning. It shouldn't have stopped that fast, especially if the other 3 tires on the vehicle didn't. So it starts off with isolation mode. It cuts you off from controlling the pressure, and kind of depends on the system. I would say in most cases it really cuts you off from controlling any of the brake pressures, but some of them might only cut you off from 1 tire at a time. And what it does is you're driving, so it locks, isolation mode, dump mode then releases the brake completely. Okay, so dump mode just turns the brake off, the tire starts to spin again. Okay, reapply mode is when it actually brings the pressure back on. So your tire got dump mode, let the tire spin again. Reapply mode turns the brake back on. Chances are, if you're on a slippery surface, it's going to lock immediately. So it goes into reapply mode, which will probably lock the tire again. Then it goes back into dump mode. Then it goes into reapply mode. Then it goes into dump mode. Then it goes into reapply mode. And it keeps doing that until the vehicle either, one, no longer has a situation where the tire locks. Like maybe you're going over an icy patch and then you hit dry pavement again. ABS isn't needed anymore once you hit the dry pavement, so it can turn off at that point, or the vehicle comes to a complete stop. Okay, so again, reapply mode, So reapply mode is when the hydraulic modulator routes fluid back to the wheel assembly during ABS operation. So again, it goes dump, reapply, and it can do that multiple times per second. So back in the day before ABS, people would do that on their own. They'd step on the brakes, they'd lock, they'd let off the brakes and spin again, they'd step on the brakes and lock, and that's what they called pumping the brakes, and now the car does it for you. Okay, so the ABS light, typically this is going to be like a yellow or orange light. It says ABS, and it'll light up in the dashboard. It's a light in the dash that warns the driver of ABS malfunction. Could also turn on when the ABS works. So if you step on the brake, your ABS turns on. That light may turn on to let you know that the ABS is doing something in your car. Not always, but typically it does. Okay, integrated ABS. So this is an ABS system where the master cylinder and ABS module unit are combined as one part. I can honestly say I have never seen one of these in person. I know they exist. I think they were probably pretty old, but I've never seen one of these in person. I've seen the definition in a few different textbooks. That's why I included it here. But I can't think of anything that actually uses this. As I'm doing this and I'm talking, some of the hybrids might actually use this because they don't really have a traditional brake booster. So some of your hybrids may actually use this again. But this was pretty old technology that kind of disappeared for a while, and everything old kind of comes back after a while. So this might come back around, but I can't think of anything right now. Just for like visual representation, this is your master cylinder, this is the ABS module. These would be like combined into one unit. That's kind of, yeah, so they'd be kind of combined into one unit. Non-integrated ABS. I'm not going to pick those parts up again, but it's where your master cylinder and ABS module are separated. And sometimes they're not even that close in the vehicle. Like Chevy trucks put the master cylinder in the normal spot, and then the ABS module like down basically underneath the driver's seat under the truck. They did that for a long time. I think they still are, but I haven't looked at any of their brand new stuff, so I don't know. So that's where they're separate pieces. Okay, ABS module. This is a separate hydraulic circuit that feeds out to one or more of the brake assemblies. So if we look at the module that I've got here, it's got 4 different spots on it. Each one of these goes out to an individual wheel. So this would be an example of one that has 4 channels. A lot of your pickup trucks would have had 3 channels for a very long time. They had a separate one for each front, but then in the rear they just ran one brake line that ran from the front of the vehicle to the back of the vehicle, and then it split off and went to both rear wheels. So they would only have 3 different channels. This is a separate hydraulic system that feeds out to one or more of the brake assemblies. Generally in today's land, we only feed 1 wheel per channel, so we'll have 4 channels on a vehicle. Okay, so the 1-channel ABS. This was an ABS that controlled only one of the circuits. They called this R-wall, which was rear wheel anti-lock. They typically use this in older pickups and large SUVs. They had that system that I talked about earlier, where it's really like 3 channels, because you had one line that ran the entire length of the vehicle that fed both rear wheels. So this ABS was plumbed in, and it only worked on that one channel that ran both rear wheels. So both rear wheels either had brakes on or didn't, depending on what the ABS wanted to do, whether it was in dump, reapply, or just standby. Okay, 3-channel. This was a very common system through, I would say, the mid-90s through like mid-2000s. So this was a very common system on trucks and SUVs. Large SUVs like Tahoe, Suburban, Durango. Durango's not that large, but it fell into this category. So this was an ABS system that controlled 3 separate brake systems. It had one channel for each front, and then the rears were on another. So that added up to 3 channels. Okay? So that would be a 3-channel. 4-channel is what we have today. So this is an ABS system that has 4 separate control circuits. Each corner of the vehicle is controlled individually. All new cars sold in the U.S. for model year 2012 and newer have this technology. So there was a federal mandate that came down that all vehicles must. They didn't actually mandate the 4-channel ABS, but they did mandate stability control, which basically made it so they had to run 4-channel ABS. So any new car sold after 2012 has 4-channel ABS. So a traction control system is a system that prevents wheel slip during acceleration. If you live in an environment that has snow or mud or sand, this is something you need to turn off. Because what it does is you step on the gas and the car tries to go, and if the tires slip a little bit, it shuts off your power or applies brakes to make the tires not slip. If you're in snow, sand, mud, I guess those would be the big ones, you need wheel slip or your car won't move. So this is one of those systems that if I get in my car and it's snowing, I just tap the traction control off system, because otherwise I'm going to go to try to move and my car's just going to sit there in traction control and try to kill me because I won't be able to move. But that's what it does. It prevents wheel slip during acceleration. So you step on the gas hard enough to make the tires spin, it shuts you down. Stability control is what I was talking about with the 4-channel system. This is now federally required. So this is a system that prevents wheel spin on acceleration and controls tire skid when cornering. So it keeps your vehicle... Oh, wait. Yeah, I brought Hot Wheels out. So what it does is a lot of things. So if you're driving down the road and for some reason your car starts to get sideways, it corrects it. Does it automatically. Your car goes sideways while it's driving down the road. It uses a combination of brakes and power. Generally, I think it only cuts power, but it may actually have the possibility to add power. But it uses this stuff to straighten the car out. All right, so it keeps your car stable and in control as you're driving down the road. It's standard on every new vehicle under 10,000 pound GVW sold in the U.S. market for the year 2012 and newer. So that's what that is. 10,000 pound GVW, your 1-ton trucks are probably going to be heavier than that, but I'm not sure where 3/4 ton GVWs fall anymore. The older 3/4 tons would not have fallen into that category. Some of the newer 3/4 tons might be over 10,000. It doesn't really matter. As far as I've seen, everybody's put this technology on their 3/4 and 1-ton vehicles as well. So pretty much any light-duty vehicle you're going to see, 2012 or newer, will have this system. Okay, so one of the things that stability control helps to control is understeer. Understeer is when the front end continues to push forward instead of turning in a corner. The car tries to go straight ahead instead of turning. So if you're talking about racing, this would be what they would consider push, or I believe they call it tight. So I've got my super special roadway drawn out here. We get our car, I'm going to turn it around this way. So we get our car running down the road. Understeers when we come into this corner and we try to turn it, and it doesn't really turn. It just kind of pushes off. Okay, so that would be understeer, push, the less fun way of handling, whatever you want to call it. This is what most modern cars are set up to do. Okay, oversteer, this is the fun one. This is another thing that stability control corrects for. This is when the rear tires lose traction in a turn and the back of the car slides sideways. So this would be, if you're talking about like racing terminology, if they call a car loose, This is probably what they're referring to. So same deal, we're driving along the road, we come to this corner, and instead of going around the corner nice and neat, the car comes in and slides sideways through the corner. Okay, so that's where the back end of the car loses traction. Oversteer is going to be more common with a rear-wheel drive vehicle. A vast majority of our vehicles now are front-wheel drive based. So oversteer is less likely to happen now than it has been in the past. So there you go. That's what oversteer is, though. Oversteer is kicking the thing out. It's drifting. It's loose. It's whatever you want to call it. That's oversteer. Steering angle sensor. And I don't actually have one of these to show you, but it measures how sharp the steering wheel is turned left or right. This needs to be reset after an alignment on most newer vehicles. I don't have a steering wheel or a steering column off a vehicle in here with me, but if we can pretend this hand is like a steering wheel, so I'm sitting here, steering wheel, and like right here behind the steering wheel is a sensor that measures how much you are turning that steering wheel. That's the steering angle sensor. That's one of our inputs that goes into the module that controls our stability control system. Okay, lateral acceleration sensor. So this is a sensor that's generally mounted kind of low in the car, kind of centralized. Sometimes it'll be in like the dashboard, sometimes it'll be in like the center console. But what this does is it actually measures the side force in a turn. So you go into a corner and your car is creating a force as it goes out. So what this sensor measures is basically how hard you're cornering. So a Yaw sensor is kind of like that, only it really measures every direction in how hard you're going. So it measures acceleration, braking, turning, all that stuff. If your car starts to get sideways or something weird like that, the Yaw sensor is probably going to pick that up as well. Okay, so this is a sensor that measures the direction and the amount of energy going in each direction generated by the car or truck. Okay, throttle position sensor. This one's pretty easy, but it's how hard you step on the gas. Most of our new cars have a drive-by-wire system, which means you step on the gas pedal, you're no longer directly connected to the engine like you were in the old ones. You've got wires that run from the gas pedal to the throttle body and sometimes back to the computer, and that's controlling your engine that way. So that ties into it because, like it needs to know everything you're doing and everything you're asking of the car. So if you floor it and turn the steering wheel, it knows that you want to go that direction as quickly as possible. The computer gets involved to try to make sure that the car does what you're asking it to do. Okay, the brake pressure sensor. So this measures how hard the brake pedal is being pressed. A lot of times that's going to be housed within this unit as well. So there'll be a pressure transducer inside of here that the harder you step on it, it's going to tell the car how much pressure you are applying to the brake system. And these are all inputs. So this is a computer system. It takes information in and decides what to do with it. So that's the end of the terms I have for ABS, TCS, SCS. There's probably more I could have included there. I definitely could have gone into more detail on all the stuff, but hopefully that's a good overview. If you made it to this point and you haven't hit the subscribe button, do it. Thanks for watching, and I'll see you later.